Dispersion is a very important optical phenomena, and it happens in the most beautiful way in a rainbow that we all like to see, that we all love to see it so much. Okay, so here in this chapter we are going to study that phenomena, and that is dispersion. And this rainbow like phenomena is can also be like kind of replicated in laboratories, okay, using a prism. Okay, so we are going to first learn some very important and interesting properties of a prism, and then we are going to move on to the dispersion. Okay, let's start with the prism. What is a prism? Okay, so this kind of structure, a transparent material. Okay, it's a three-dimensional object. It's like this. This is our prism. Okay. Okay, it's like this is a three-dimensional structure. Okay, it extends out of this plane. Okay, it's kind of there are three faces, and there is they extend out of this plane. So this becomes our prism. Now let's say that some light is incident on this prism like this. This incident like this. This is my normal here. Okay, let me draw it this way. Now this is normal. This is normal. Okay. This is my angle of incidence. Angle of incidence. This angle A is called prism angle. Angle of prism. Angle of prism, or it is also called the refracting angle. Refracting angle. Okay. Refractive index of this prism is, let's say, mu. Okay. So here at this point refraction happens. This is the original direction of our incident ray. Original direction, and at this point the light ray is going to bend towards the normal. This is by normal. Okay, it is going to bend towards normal like this. Let's say that this is how it bends. Okay, this angle I am calling it as R. This is R. Okay, at this point again there will be refraction. Okay, this is normal to this surface here. This is normal. Okay, this light is again going to bend. Okay, I am extending this line here. It is going to bend again. Okay, now it will bend away from normal. The light is going from denser to air, that is rarer medium. Okay, so it bends like this. Now this angle here, it is known as angle of emergence. Okay, this is angle of incidence here, and this is angle of emergence. Light finally comes out in this direction. Okay, this was the original direction of my light ray. Finally it comes out in this direction. Okay, so what is the deviation? This is deviation. Okay, so let me extend it here. This is deviation, delta. Okay, angle of incidence, this is angle of emergence. Okay, makes sense? Now what will be delta? If you look at these angles, you see this angle is 90 degree, it's a normal. This also is 90 degree. Okay. Let's say that this angle is alpha and this angle is beta, let's say. Okay. So what is delta? Delta will be equal to alpha plus beta. Okay, makes sense. Now, this angle here, this angle I am calling it as R dash. Okay, R and R dash. Alpha, what is alpha? This whole thing is I. So this alpha becomes I minus R. Okay. This becomes I minus R. Okay, plus beta. This angle will be E. This whole thing is E minus R dash. E minus R dash. Okay. This becomes equal to I plus E minus R plus R dash. Okay. Alright. Now, what will be this angle here? This angle here. What will be this angle here? This angle is equal to R plus R dash. Okay. So this angle will be pi minus this thing. Okay. Look at this quadrilateral. Okay, let me say it is a P. This is Q here. This point here is R, PQR, and this point here is S. In PQRS, this angle is a right angle here. This angle is a right angle. Total sum is 180. In this quadrilateral, total angle is how much? 360. 360. This is 90. This one angle here, this one angle here is 90. The other angle here is also 90. 90 and 90. It becomes 180. That means this angle here plus this angle here, it should be equal to 180. 90, 90, 180. This plus this, it should be equal to 180. That means this angle here it is equal to pi minus A. This angle is pi minus A. That means this angle here, this angle is going to be equal to A. This angle is A. And A is equal to R plus R dash. Okay? R plus R dash is equal to A. Okay? Makes sense? Do you understand this? Simple geometry. Okay? Now what is deviation? Is equal to I plus E minus A. This is something that you have to remember. This is our first important result. I plus E is minus A is equal to delta. What is delta? Deviation. Deviation. Okay, now one other very interesting thing. It's like this. This is angle of this is the incident light. It finally emerges in this direction. Okay. Now use the reciprocity. Reciprocity. Such an important tool. We have been using it in several places. Reciprocity. If I send my light in this direction, then it is going to come out in this direction. Okay? Okay? That means what it means is, that means what it means, and there will be, delta will be same. It will be same delta here. Okay? So if I is replaced by E, okay, if I is replaced by E, we get if I is replaced by E, we get same delta. Okay, that means we get same delta for two different values of I. A very important observation. Okay, if I keep on changing my I, I am going to get same deviation delta for two different angles of incidences. A function has same value, a function achieves same value for two different values of the input. For two different input, output is same. Okay, so I have a function of this type. This is some variable x. Okay, and this is my function fx. Y is equal to fx. Let's say. Now this function has a property that for two different values of x, I am going to get same value. Okay, that means the function is going to look either like this. Okay, in that case, I am going to get two different for two different values of x. I am going to get same value here, or it is going to look like this. That means that function absolutely is going to have either a maxima or a minima. A very simple mathematical fact. For two different values of x, x1 and x2, I am getting the same value. Here exactly same thing is happening here. For two different values of I am getting same deviation. That means for a particular value of I am going to get a minimum deviation. Okay. In this case, minimum happens, and if I plot the graph, here, this is angle of incidence, and this is deviation. Okay, and if I plot it, I am going to get graph like this. Okay, for two different angles of incidence. Now, what are those two different angles? That are angle of incidence and angle of emergence for this pair. Okay, let's say that angle of incidence is 30, angle of emergence is 45. For example, I get some delta. Now, if angle of incidence is 45, I am going to get the same delta. Okay, this is delta. Now, at one particular value, it is going to be minimum. This is known as I minimum. I minimum is not the minimum angle of incidence. Minimum angle of incidence is going to be 0. Okay. I minimum is the angle of incidence corresponding to minimum deviation. This is minimum deviation. Okay. Now let's write down few properties. Okay. In case of minimum deviation, okay, I is equal to E. Both become equal. Okay. So this is I1 and I2. Okay. Now for this case, both become the same value. So I is going to be equal to E. Now if I is equal to E, then these two are also going to be same. Think about it. If I and E are same, these two are also obviously, okay, I don't need to explain it further. These two are also going to be same. Okay. So in case of minimum deviation, I is equal to E and R is equal to R dash is equal to what? R plus R dash is equal to E. A is equal to A. Both are equal. They will be equal to A by 2. Okay, and then delta minimum becomes equal to 2 times of I minimum minus A. Let's say it is equal to I minimum here. Okay, do you see this? Okay, so what will be I minimum? It will be equal to A plus delta minimum over 2. Okay, so now let's apply Snell's law. Okay, here 1 times sine I minimum is equal to mu times sine R. Okay, so what is mu? Mu is equal to sine I minimum over sine R. Okay, and then let's replace these values. Okay, so I get mu is equal to sine A plus delta minimum over 2 divided by sine A over 2. That's all we have to do. In case of Prism. Okay, note down all these things at one place. Note down everything, all the formulas. The derivation is quite simple. Generally, we try to run away from the derivations. Okay, but we should not run away from the derivations. So derivations give us in-depth understanding about the concept. Okay, you should never run away from the derivation. They are very important thing. Okay, and in this particular case, the derivation itself is very, very beautiful, simple. This is a mathematical derivation. We are using simple mathematics and we are deriving this beautiful result. Okay, here this graph is especially useful. Okay, problems are asked on the basis of this graph. Okay, and you see this side, everything this side here is general property of prism. General property. Okay. On this side, all the results here are only for the special case. Special case of what? Special case of minimum deviation. When the deviation is minimum, at that time only these things will happen. This is a general property for any angle of incidence, for any deviation. Okay, so we have to remember the results, general as well as this is special case of minimum deviation. Okay, let's do few problems. Things will become very easy. Okay. Note down everything at one place, because when we are going to do problems, we will not really have a chance to refer back to the same thing again and again. Of course, you will waste your time if you do that. It's better to write down at one place. Okay, that way you can very simply do all the problems. Okay, very quickly also. Okay, let's start with some problem. First question is like this. I have this prism. This angle is 75 degree, and I have this incident light. This is 45 degree. This mu is equal to root 2. Let's say it is equal to root 2. Okay, find E, not E, but R dash, E and delta. That's what we have to find. Okay. Second case. Second problem. This is mu is root 2 here. This is 60 degree. Okay. Find I minimum and delta minimum. Okay, direct problem, simple problem. I minimum and delta minimum. Let's do one more. Okay, delta I graph of a prism is given. Okay, find angle of prism. Angle of prism. It's like this. This is I and this is delta. Okay, it goes like this. Okay, this is a 30 degree, this is 30 degree, and this is 60 degree. Okay, for two angle of incidences, delta is same. Okay. Let's solve. Let's start with this. Then we are going to do few more problems. Okay. All right. Now what about it? Let's see. R and R dash. Note down the problem. We are going to do it very quickly. They are simple problems. Very simple problems. We are not going to take much time. It's a simple topic. Very simple topic. Short topic. Interesting topic. If you are able to understand. Okay, otherwise no. Okay, so we are going to do this very quickly. Okay, let's see. So you should pause the video now, right now. You should pause it. Okay, forget about the video, forget about me. Okay, forget about everything. Then sit down and solve all of this. And now we are going to discuss it. Okay, it's like this. Okay, so I have this prism, and this is how my light enters. This is 45 degree, This is, let's say, first point here. So this light is going to bend, okay? This light is going to bend towards the normal. It is going to bend like this, something like this here. Okay? And then again, it is going to bend. Okay? It's something like this here. So this is angle of emergence. This angle here, we call it as R. Okay? And the angle here, we call it as R dash. Okay? This is point 1, this is point 2. At point 1, let's apply Snell's law. Okay. So 1, and this mu is given root 2. This angle is given 75. Okay. 1 and sine 45 is equal to root 2 and sine r. Okay. So 1 over root 2 is root 2 sine r. Sine r is half, r is 30. Well, we got it. I got it. R is 30. Okay. R is 30. What will be R dash? What will be E? I can find R dash either by remembering the formula of Prism, those certain relations between different angles, or just in case I forgot it, then also I can do. It's like this. This is 30 degree. This is 30. Okay. What will be this whole thing? This whole thing here will be 60 degree. Okay. Now this is 60. This is 75. It becomes what? It becomes 135. 60 plus 70. 75. It becomes 135. So what will be this angle here? It will be 45. So what will be this angle? R dash. It is 45. Without using any physics, any relation. Or if you want to use relation, you can do that. R plus R dash is equal to A. You see how we are doing it, okay? So R dash is equal to A minus R. So this is 75 minus 30. It becomes 45 degree. Well, do you see this? Okay, you see this? 45 degree. Now, second point. I'm going to apply Snell's law at here. At this point also reflection takes place. I will write root 2 sine r dash is 1 and sine e. Okay? Understand? So this is root 2 times r dash is 45. 1 over root 2. 1 over root 2 is 1 and sine e. Okay? So this thing sine e is 1. E is 90. This is angle of emergence. It's critical angle. You see, this is mu is root 2. What will be critical angle? 45 degree. And this is 45. That means it is going to pass like this. Okay? We calculated this. Now after this, I can either use, now I want to find this. So if I remember the relation, it's very good. Okay? And if I don't remember it, then it's perfect. Okay? Then in that case, you will be forced to use your brain. Okay? Now let's use our brain. This thing is 90 degree here. That means the light ray is actually passing like this, tangentially. This is E, is 90. Okay, let's try to find angle of deviation without using any relation, directly using simple geometry. This is my incident light. Okay, and this is how the light finally emerges out from the prism. So isn't this my deviation? That's all I want to find out. Now what this will be? This is 45. This is 45 here. That what it means? That means this whole thing here is 45. This whole thing. Out of that, this is 30. That means this remaining angle here is 15 degree. 15 degree. Okay, makes sense? Now, 15 and this is 45. So this delta is an external angle for this triangle here. External angle, okay? It is going to be simply equal to 15 plus 45 is going to be equal to 60 deviation. Just in case you have any difficulty, if you have difficulty applying this simple geometry, then you will have to remember formulas, okay? Formulas, okay? So this I can write as I plus E minus A. I am going to get exactly same answer, okay? You will see. This is going to be equal to I. What is I? 45, okay? 45 plus, what is E? 90. 90 minus, what is A? 75 here. Isn't this 60 degree? It will be 60. Check it. Both are same. Okay. So we do not worry too much about formulas. And that is the philosophy of this course. We have never worried too much about the formulas. We have actually tried to avoid it as much as possible. Okay. That's what we do. we avoid using formulas. Okay. Because how much formulas do you think you can remember? And you can remember the formulas now. Now you can remember it because you are like having this class. What about tomorrow? What about day after? 1 month later? 1 year later when you are required to sit for your exams? Can you remember all the formulas? Chances are you will forget most of them. It's better to understand the basics. Okay? Okay, so second one. Let's apply formula directly. Okay, because it's a case of minimum deviation. So we have this formula. Okay, it is mu is sine. Okay, A plus delta. Sometimes we write it as this also. Delta m. M is for minimum. Okay, over sine A. That's it. Okay. Okay. So what I have is this is given. This is given. Okay. Okay. So this mu sine A by 2 is sine A plus delta m over 2. It's like this, okay? This is root 2, okay? A by 2. What is A by 2? Okay? This A by 2 thing is going to be sine kind of, what it is? 30. A by 2 is 30, okay? Sine 30 is equal to sine A plus delta m over 2. This is going to be, this whole thing is actually going to be equal to root 2 and 1 over 2. This becomes 1 over root 2. 1 over root 2, okay. This is 1 over root 2 is sine A plus delta m over 2. Okay, so what that means A plus delta m over 2 is going to be 45. Okay, makes sense? It is 45. A plus delta m over 2, 45. So A is given. Okay, so delta m is 90 minus A. This is 30. This is 30 degree. This is deviation. 30 degree. What about I minimum? I minimum. Okay. How do I find out? What is I minimum? Okay, so we have several ways of doing this. Delta m. Delta is equal to I plus E minus A. General thing, in any case, we get this just using simple geometry. Okay, we did it in the beginning itself. In case of minimum deviation, okay, I is equal to E. Okay, so this delta m is 2 times of Im minus A. I can use this thing here. So I minimum is equal to A plus delta m over 2. $45. 45. I can do it in one other way also. Let's look at that way also, so that gets into your head, okay? And it becomes easier for you to remember and easier for you to relate correlate and connect different points. It's like this. Okay, it's like this. In case of minimum deviation, okay, R is equal to R dash is equal to A by 2. R is equal to R dash is equal to half by 2. Okay, so here R is going to be equal to 30 degree. Now what is R? Okay, this is I. Okay, and this thing here is R. Okay, this mu is root 2. Let's see what answer we are going to get. We are going to get the same answer. 1 times sine I is root 2 times sine R. Okay, so sine I is root 2 times 1 over 2. Sine R, 30 degree. Okay, so it is 1 over root 2. What is I? 35. We got the same thing. Okay. Now, one very interesting thing about this minimum deviation. What is so interesting? Okay. We did not discuss it earlier. Let's look at that now. In case of minimum deviation, these two angles are going to be same. Okay. What are these two angles? This is I. Okay. This is R. This is R. And this thing is R dash. This thing is R dash. Okay. Now, if these two are same, try to understand this, very, very important. If these two are same and these two same also, they will also be same. This is theta, this will also be theta. This is A. That happens only in case of minimum deviation. We say that light passes symmetrically through the prism. What is the meaning of symmetrically? These two angles are going to be same. Now, in many books, in most of the books, in many, even the standard resources, what is written is that in case of delta minimum, light passes parallel to base. Now this is like a garbage statement. I don't really like to use such harsh words, but this is absolutely garbage. Okay, this happens in few cases, only special cases. Okay, now just I am giving you some one very simple example. If my prism is like this, let's say that this is my prism. This is my prism. Do you think this light is going to know how the base looks like? Light has brains. Okay, it has in its own way. Okay, but do you think that light is going to know? Or if I start this, if I start with this prism, and if I keep on fighting it, I keep on fighting the base. Okay, I keep on changing the base. Do you think that this light will keep on changing? Will it be parallel to the base? Okay, this actually is a garbage statement. It is a garbage statement. Okay, for example, if I have a prism like this, I can have a prism like this. Okay, and in this case, light is incident like this. Okay, and I'm saying that it is a case of minimum deviation, and how the light ray will pass inside this prism. it will never be parallel to the base. It will be like this. It will pass symmetrically like this. This is how the light is going to pass. These two angles are same. This is A. These two angles are going to be same. In case of minimum deviation, it may not be parallel to base. It becomes parallel to base only if I have a prism like this. Only in this case, okay. Here, okay, these two angles are same, okay. And then coincidentally, it's just a coincidence that this turns out to be parallel to this. It's just a coincidence. Okay, this is not the general case. Okay, so do not remember this. Never remember this. Remember this, that light passes symmetrically through the prism. These two angles are going to be same. These two are going to be same like this. This is the case of minimum deviation, when these two are same. Okay. Well, let's move on to the next one. This one is pretty simple. Okay, what it says is that I have this delta I graph. Okay, for two different angle of incidences, I am getting this same delta. What it means is if one of them is angle of incidence, the other one becomes angle of emergence. As simple as that. What is delta? Delta is I plus E minus A. Okay, so this is 30 is equal to I plus E. 30 plus 60 minus A. What is A? 60 degree. Okay, A 60 degree. Okay, that's it. That's almost it. Okay. Now, okay, you are going to find many problems in a problem sheet. Solve those problems. From Prism, most of the times simple questions are asked. Okay, simple questions based on the relations only. You can answer most of the problems. Okay, so try those problems. If you are, and we are going to discuss it. The problems which you find difficult, of course, we are going to discuss those problems. And okay, let's do just one problem, and then we will move on to some other topic. Okay, it's like this. Deviation produced by the prism is delta. Deviation produced by a prism is delta. Okay, it's like this. I have this prism angle. This is known as prism angle, angle of prism, or refracting angle. Okay, different names. So some light is incident like this. Okay. This is the light angle of incidence I. Deviation is delta. Deviation is delta. Now look at this. Question is, okay, what is net deviation? Net deviation if identical prisms are arranged or kept in contact as shown. I have this prism here. This prism produces this deviation delta. Now what will happen if I place some identical prism in contact? Okay, it's like this. First case here. This angle is A. This is an identical prism. Okay, identical prism. This angle is also A. My light is incident here at the same angle. Now what will be deviation in this case? What will be deviation? Okay, and then second case. This is A, this is A, this also is A. The light is incident in the same manner. This angle is I. What will be deviation here? Okay. Can you answer it? Okay. Got it? Can you answer this? Okay. Let's say the deviation is A here. This is deviation A. Okay. Now what will happen if I invert this prism? I am inverting it. This is deviation delta in clockwise direction. In clockwise direction. Now if I invert this prism, invert it, okay, and then light is incident in the singular manner here. In the singular manner, okay. It is, let's say it is like this here, okay, or it is going to fall like this, okay, in a different way. It is going to fall like this here. Angle of incidence remains the same. Okay, what is the difference between this case and this case here? Okay, so here also there is going to be deviation. This is the original light ray. Here's how it is going to be deviated. Okay. That's how it is going to look like. Okay. Now this becomes my deviation, delta. What's the difference? One is clockwise, the other one is anti-clockwise. So whatever deviation is produced from this in clockwise direction, this is going to produce exactly same deviation in opposite direction. So what is okay? So what is delta net? It is going to be 0. Okay. And you see there is one very beautiful thing about it. Okay. Do you know why it happens? This is one reason. This is, if this is producing clockwise deviation, this will produce same amount, equal amount of anti-clockwise deviation. Net is going to become 0. Now there is one other reason for this net deviation becoming 0. Do you know why? Can you find out why it is happening? It is because this is, you see, at this point refraction will happen. Do you think it will happen? Identical, both are identical prism, okay? So whatever is mu here, it will be same mu here. At this point, the light does not feel any change in medium. It does not feel any change in medium. Okay? Do you see? So it is going to pass undeviated. Okay. Now it will experience a change in medium if there is some separation here. If there is some separation, in that case it is going to experience some change in medium here. If they are placed like this with some gap here. Okay. In that case, it will emerge like this. It will emerge like this, and then it will enter the prism. It will enter the prism. And then it comes out like this. It will be shifted somewhat, but still it is going to be parallel to itself, the original direction. There is one other reason for this. Look at these two faces. These two faces. What are these two faces? They are parallel. So it is like a glass slab. It is like a glass slab. Okay, so I have this light ray. Okay. So when the light passes through this slab, okay, it bends a little bit, and then finally when it comes out parallel to itself. There is lateral shift. The same thing is happening here. These two sides are parallel. So I can explain this thing either using this concept or using this concept. Both are actually same. There is no difference as such. Okay, think about it. Okay, so deviation produced by this. will be balanced by this. Okay. So these two prisms are redundant. Redundant. What is left? What is left is same as the original one. In the original one, deviation is delta. Here also deviation will be delta. This answer will be delta. Okay. All right. You understand? Okay. Let's move on to the next topic. The next topic is thin prisms. Okay, thin prism. Thin prism. Okay, A is very small. A is very small. Okay. Now, okay, mu we write as sine A plus delta n over 2 divided by sine A over 2. Okay, now if A is small, then delta is also small. Also small. Okay, so I can write sine A by 2, approximately A by 2 here. Okay, and sine A plus delta m over 2, this also approximately A plus delta m over 2. Okay, now let's make some rearrangement here. This is this becomes A plus delta m over 2 and A over 2. Okay, so mu times A is going to be equal to A plus delta n. Delta n is mu minus 1 times A. For a thin prism, when angle A is very small, let's say few degrees, 2, 4, 5, 6 degrees like that, small angle, then this will be minimum deviation. Okay, now if angle of incidence I is also small, then this is minimum deviation if A is small. So if A is small, it is thin prism, and angle of incidence I is also small. In that case, delta is approximately equal to delta n. So whatever deviation is produced is actually the minimum deviation. Okay, and that will be equal to mu minus 1 times 2. Both are equal. Okay, question. Find net deviation produced. Net deviation. Okay. First case. This is 6 degree. This mu is 1.5. Let's start with this simple problem. Okay. Second case. This is 6 degree. This is 1.5. This is 4 degree. This is 1.2. Okay, let's say. And then third one. 6 degree. Mu is 1.5. And here I have, this is 4 degree. Mu is 1.2. Same prisms arranged in different manner. Okay. What is going to be net deviation? Okay. What do you think? Pretty simple question. Very simple question. Okay. First case, deviation is simply equal to mu minus 1 times A. It is 1.5 minus 1 times 6 degree. This becomes 3 degree. For deviation of 3 degree. for small angle of incidence. If angle is not small, in that case this becomes the minimum deviation, you see. But generally when nothing is specified, nothing is specified about the angle of incidence. By default we assume small angle of incidence. Okay, now here, so it is going to produce a deviation like this. Okay, some small deviation. Okay, now what about this case here? Okay, think about this. Now this is the first deviation. Okay, this is the first deviation delta 1. Okay, think about it. And then this is the second deviation. Okay, both deviations are in the same direction. This is my light ray. This light ray undergoes deviations from both prisms. So total deviation, so delta 1 is equal to 0.5 times 6, this is 3 degree. Delta 2 is 0.2 times 4, this is 0.8 degree, 0.8. What will be net deviation? Delta 1 plus delta 2. It is going to be what? It is going to be equal to 3.8 degree. Delta 1, delta 2. Light ray undergoing successive deviations. Okay, total will be equal to summation of all successive deviations. Here they are in opposite direction. If you start with one light ray here, one light ray, okay, this undergoes this deviation here. Okay. Now at this point again there is going to be deviation. Okay. Now, so this is my normal. Okay, it is going to like kind of something like this. So they are producing deviations in opposite direction. Okay. The things become more clear if you separate them a little bit. Okay, if you separate them a little bit, things will become very clear. Okay, but we have discussed this point already. Already we discussed it when we were discussing Prism. Okay, just a few minutes ago we did it. So I just have to write delta 1 minus delta 2, mod of that. Okay, the resultant will be equal to 3 minus 0.8. This will be 2.2 degree. Okay, now simple problems are asked. Simple problems are asked depending on this simple expression, simple formula. Okay, this is about prism. Okay, now should we start dispersion in this class itself? What do you think? Should we start dispersion? Okay, in this class? Let's do it in the next class. Okay, dispersion. So whatever we learned here, especially the thin prism, remember that formula, that relation for the thin prism. Okay, we are going to use that in explaining dispersion and finding its formulas. Okay, in the next class.